x plus 7, x minus 7. Can I reverse those? Yes, because multiplication is commutative. What is this one? 3x minus 5y, and then 3x plus 5y. What's this one? Can't do it like that. What do you got to do? Bring out the 2. X squared minus 25. Can I forget about that 2? No. X plus 5, x minus 5. What about this one? X squared plus 1 and... Can I stop there? No, of course not. Why? X squared plus 1, x plus 1, x minus 1. This one, multiply to what? 60. Add to what? Negative 17. What is it? Negative 5 and negative 12. X minus 5, x minus 12. This one.
I did x minus 3 and x minus 20.
No, because minus 3 minus 20 would be negative 23. 6. A minus 11, a plus 11. 7. What do you got to do first? GCF, the type of factoring you're supposed to do every time you can. 3. X squared minus 16, 3. X plus 4, x minus 4. What do you got to do first in 8? Bring out the GCF, which is A squared minus 16, A plus 4, a minus 4. What do I got to bring out here? 8, a squared minus 9, 8, a plus 3, a minus 3. 10, tricky, but not. Why? It's in a different order, but they're both perfect squares, aren't they? So, what's the square root of 1/9? 1/3 plus what's the square root of x squared? X. Then I write it again with a negative. What about this one? Multiply to what? Negative 5. Add to what? Negative 4. Is it 1 and 5? Of course it is. Which one's the negative to get to negative 4? Negative 5. So it is x plus 1, x minus 5. This one, multiply to 9, add to 6. What is it? X plus 3, x plus 3. How could I write that a different way that would get me the same credit? X plus 3, all squared. 13. What's the first step? X to the 4th plus 4, x to the 4th minus 4. Am I done? No. Why? X squared plus 2, x squared minus 2. Am I done? Yes. Why? 2 doesn't have a square root. Is everybody good for factoring? All right, now listen to me, please. Tomorrow, you are going to write a quiz on the first 2 types of factoring. Okay? So you're going to write a quiz on GCF and x squared plus bx plus c. Those 2. None of the square root stuff yet. Okay? I'm not going to be here tomorrow. I'm going to be dealing with a court thing. I won't be here tomorrow. I'm hoping to get the same dude I had on Friday. I will leave you with a ton of factoring practice for what we're going to do today and other stuff. All right? And you'll be writing a quiz. Hopefully I'll be back Friday. Oh, crap. The next thing isn't on here. Talk amongst yourselves for a minute while I get the next thing. What? No, I just said I'm going to a court thing. That doesn't mean I'm going to play tennis somewhere.
Are you going to get arrested?
No. I have to appear in court as a witness for something. What page of your books is the next page? 165?
Imagine trying to wrap a basketball without putting it in a box. That would be so hard. Like wrapping it like a ball and then kind of like you know like you know how like you might have a thing where you kind of like wrap it and then like push it outside so it looks like yeah, and like you can use that thing where you like roll it and then you like push the side so it kind of looks like a candy. But like that's what it looks like. We did it for a jacket. He didn't put it in a box. He was like, oh, let's just wrap it.
No, but like, what if I don't like? I don't want to talk to him about like. Yeah, I'm. Actually, no, my she's been nice to me. Like, I'm just like cool, but I don't want anything in the I'm not gonna get involved. Because I really. No, but I was kind of ignoring this person. It was like, oh, is there going to be black or something? Yeah, and I just walked away. I was like, I don't have a reason why I did this shirt. Honestly,
All right. All right. Ladies and gentlemen, we are back. Page 169. Expand that for me using the shortcut, the quickest way you possibly can. What is it? Should take 1 second. X squared plus 10x plus 24. Excellent. Why? Because you know you add them and multiply them, right? And when you factor, if this wasn't here, then you know that to factor this, you need to multiply to 24, add to 10. Correct? All right. Everyone is good, yeah? All right. Is this a factor or a product? Factor. How do you know it's a factor, Selena? Not necessarily. Because there's something, a single thing, grouped by brackets, multiplying by another single thing. That's what makes a factor. What is the product? 6x squared minus 4x plus 3x minus 2, which equals 6x squared minus x minus 2. Is everybody cool to there? That's just expansion. We're good, yes? And that makes this the product, right? Which means, since it started as factors, there must be a way to factor this. Because we have the answer right here, don't we? Right? Now, thanks. If I can factor this, does this look similar to that? How? Describe the similarities to me. There's an x squared. There's an x. There's a constant. So there's a quadratic term, a linear term, and a constant. Yes? Excellent. And we know that this will break down, don't we? Now we know that when we factor this, we did times and plus, yeah? And this looks really similar to this, doesn't it? So we are going to use the same method. Now listen to me carefully. I personally know of 3 different ways to factor this. All 3 of those ways work. One of them I hate because it's guessing. And why in math would you guess? There's never a need to guess in math because you know how to do math. So I don't like using that way. Unfortunately, that is the way that almost everybody teaches now. I don't like it. I will not teach it to you. If you wish to learn that way, you can find it yourself. The second way to do it is the way I was taught, which is a little bit confusing, and it leaves you with questions like, it leaves you with expressions like this, which can also be a little bit confusing. The third way is a way I found about 7 years ago when I was pulling out what was left of my hair to try and find a way to teach you how to factor these easily. And I used the internet to not look up epic fails of 2011. I used the internet to find new ways to factor. And I found a very, very easy way that is based on this thing that you can already do with one extra wrinkle. Everybody cool? So we're going to use that way because it is the best way, trust me. You are welcome to use another way if you already know how to do this another way, and you are welcome to search any other way to do this, okay? Let's start. So we know that we have 6x squared minus x minus 2. Yes? Now, describe to me the number one most glaring difference between this thing that we already know how to do and this thing that we're learning today.
6.
Preston, the 6, right? Now, in previous questions, we've had a number there, haven't we? And we've gotten rid of it by dividing it out, yes? Can I divide that out here? No, so we're stuck with it. So that x, or that 6, that 6 means this x is 6 times bigger, doesn't it? Than this guy, right? So in this guy, we needed to multiply to 24, correct? Well, if this trinomial is 6 times bigger, what do you think we need to multiply to? In this one, I multiplied to 24 when there was a 24 at the end. Here I have a 2 at the end, and the x is 6 times bigger than I think it's going to be. So what do you think I have to multiply to? Because I haven't told you how to do it. I'm asking you to think. Negative 12. Why, Selena? Excellent. So here I am going to multiply to negative 12 because when there's no 6 there, I'm going to multiply to 2, right? But there's a 6 there now, so I got to multiply to negative 12. Is everybody cool? Ganika.
So whenever we get a question like that, so we always get the, what are the terms called again?
You take the quadratic term, which is usually referred to as a, and you multiply it by the constant, which is c. That gets you this. Is everybody good? Yes, McKenna. Because the 2 is negative. Absolutely. Is everybody good? All right. Now, we don't change the adding. I still add to negative 1. Is everybody good? Great. What are the factors of 12 that will get me to negative 1? Are they 1 and 12? Are they 2 and 6? Are they 3 and 4? 3 and 4. How will 3 and 4 get me to negative 1? 3 minus 4, correct? So I would write x plus 3 and x minus 4. I have spread them apart for a reason. The 3 and the 4 only work because we multiplied by 6, didn't we? When we're factoring, we're trying to reverse multiply, aren't we? What is the reverse of multiplying? Division. Have we done any division yet? No. The only reason that we knew that it was 3 and 4 was because we were looking for 12, yes? And the only reason we knew it was 12 was because we multiplied by 6, yes? So the only reason we know 3 and 4 is because we multiplied by 6. So we better get rid of that multiplication, correct? How do I do that? What gets rid of multiplying? Division. So I'm going to divide by 6 and I'm going to divide by 6. Is everybody with me? The only reason I knew 3 and 4 was because I multiplied by 6. So now I got to get rid of that 6. Ganika. By the quadratic term, which is a. Now, would you ever leave that fraction? No, what would it become? 1/2. Would you ever leave that fraction? What would it become? 2/3. Now I have x plus 1/2 and x minus 2/3. Please look at that and tell me any similarities you see. You see all the numbers, don't you? Right? Everyone agrees? Okay. Now, without thinking about why what we're about to do is going to work, what do we do here to get to what we know the answer is? Just tell me what we physically do. Selena. You move the denominator to the coefficient. And I get 2x plus 1 and 3x minus 2. And that's the answer. Now I'm going to ask you to put down your pencils, pens, crayons, stone tablet and chisel, whatever you are using to write, and just watch for a moment. Because the hardest thing I think here is why we divide by 6 and why this works. Okay? Why we're just allowed to move the denominator. Everybody cool? I'm going to show you why, and you're just going to watch. 6x squared minus, was it minus x or plus? Minus x minus 2. First thing, I'm going to show you why that dividing by 6 works. What bothers you here? The 6. We could, if there were GCFs, we could pull everything out, yes? But there isn't a GCF. But let's just divide by 6 anyway. Now, I get x squared minus 1/6 x minus 1/3. Is everybody cool? Now that looks like something we've already done, yeah? Everyone agree? Okay. So if we had no number here, we would multiply to 1/3 and add to negative 1/6, wouldn't we? Everyone agree? Okay. So if I had factors here that added to negative 1/6, I'd be in business, wouldn't I? Yeah? Okay. So if I can break down 1/3, I'd be ready to go. Now 1/3 is tough to break down because 3 is a prime number, right? Everyone agree? But isn't 1/3 also 2/6? Everyone still cool? Now we can find factors of 2/6, can't we?
So technically, was there like even a point to reduce it? Like why did we reduce it from the initial 2/6?
Oh, because you guys would automatically have done that. Right? I'm just showing you what we can do. So this is really 2/6, right? So what are the factors of 2/6? I need to add to 1/6, right? So So I got to have factors of 2 sixths that will add to negative 1 sixth. It's going to be 2, right? Sixths and 1 sixth, yeah? They'll add to here, won't they? But will they multiply to 1 sixth? No. So, if we have this and we can figure this out, we're going to be left with x. Since that's negative, it's going to be minus and x plus, yes? And we know that these are both going to be fractions, aren't they? Everybody cool? And we know that those fractions would have been just remind myself, minus 2/3 and 1/2. Okay? Now, check it. What's 2/3 times 1/2? What is that? 2 sixths, right? Everyone agree? What is 2/3 minus, or negative 2/3 plus 1/2? That's negative 4 sixths plus 3 sixths, yes? Which is what? Negative 1 sixth. So there's our factors, right? Everybody cool? So that gets me the same thing as I got right here using this method that we already know and no fractions. Everybody cool? So we can still do it with fractions. It's just barfy. Yeah? All right. Now I want to explain why we're just allowed to move those. Okay? And it requires you to take an algebra leap with me. Right now, I have x minus 2/3 times x plus 1/2, correct? Is that an equation or is it an expression right now? It's an expression, which means we can't solve it, can we? What if I make it equal 0? That times that equals 0, right? Which means either the blue or the green, one of those would have to equal 0 for this to be true. Does everybody agree with me? If this is 0, then whatever this is, the answer is going to be 0. If this is 0, then whatever this answer is, that's going to be 0, right? So either x minus 2/3 has to equal 0, or x plus 1/2 has to equal 0. Everybody agree? If either one of those is 0, this is going to be true, right? How would you solve this?
Oh, you multiply by...
X would equal 2/3, right? And x would equal negative 1/2, yeah?
But aren't
Just
the two x's the same thing?
no.
But they're the same variable.
Just trust me. Okay? If x is 2/3, this will be 0, won't it? But this will be 2/3 minus 1/2, which is 1/6. So even though x could be both, it wouldn't. Only one of them will end up with a 0.
Yeah.
You cool?
Oh, yeah, okay.
Yeah? Okay, so everybody sees how this works, right? All right, now watch. What do we know the right answer to this question is? We know that it's 3x minus 2 and 2x plus 1, don't we? We know that these two are the same thing because we just proved it, right? So, we also know that if this is 0 or this is 0, we're okay, right? So, 3x minus 2 equals 0. 3x equals 2, x equals 2/3. See? Or 2x plus 1 equals 0, 2x equals negative 1, or x equals negative 1/2. Everybody see? This is why I'm allowed to just move those to the front. Because I end up with the exact same numbers. Do you have to be able to do all this? Not right now. I just wanted you to see it to show you why I can move that 3. It's not magic. I don't just get to do it because I wanted to. Everybody cool? Because you can see we end up with the same answers even if we do the long, yucky fraction thing over here. Everybody good? The whole point of it is to show you that that add, multiply thing still works even though this looks totally different. Right? So let's try one. The first one's actually quite difficult because the numbers are big. What's ugly there? The 20. What do I want to do? I got to get rid of it. Can I divide it out? No. So I got to multiply this. What do I got to multiply to? 200. What do I got to add to? 33. Is it 1 and 200? 2 and 50? All right. 2 and 100? 4 and 50. 4 plus 50 will get me 33. Great. 5 and 40. 25 and 8, right? 8 and 25. How will they go together to make 33? 8 plus 25. So it's x plus 8 and x plus 25. But it's not really 8 and 25, is it? Because we multiplied by 20. So it's really 8 over what? 20. And really 25 over what? 20. Would Mrs. Bag Crumble let you leave that fraction? What is it? 2 over 5. And what's this guy really? 5 over 4. What do I get to do with my denominators because of what Mr. Myers just showed me? I get to move it to the front. So what's the first factor going to be? 5x plus 2. And what's the second factor going to be? 4x plus 5. Now, Mr. Myers, that's a lot of weird steps, and I know you proved it to us, but I don't know. I don't trust you. What's 5 times 4? 20. Oh, we should have been using b's. Sorry, guys. What's b times b? B squared. So is 5b times 4b 20b squared? Yep. What's 2 times 5? 10. What's 5 times 5? 25. What's 2 times 4? 8. Is 25 plus 8 33? So did we do it right? Is there ever a reason to hand me in a wrong answer in a factoring question? No. Why? Because you can check it. Look at the next one. What bothers me? The 3. Can I divide it out? No. So what do I need to do? So I need to multiply to what? Negative 30 and add to what? Negative 13. What is it? 10 and 3? 10 and 3. How do 10 and 3 get me to negative 13? It would be negative 10 and negative 3, right? But when they multiply together, won't I get positive 30? So it can't be 10 and 3. Is it 2 and 15? Yeah. How do 2 and 15 get me to here? 2 minus 15. So it's s plus what? 2, but it's not really 2. It's 2 over 3 because we multiplied by 3. And it's s minus 15, but it's not really 15. It's 15 over 3. Now what do I do to any fractions I see? Simplify them. Does that simplify? No. Does that? To what? Negative 5. Now, what do I do with any leftover denominators? Move them. What's the first factor going to be? 3s plus 2. What's the second factor going to be? S minus 5. Then I check. Is 3s times s 3s squared? Is it? Yep. Is 2 times negative 5 negative 10? Yep. Is negative 15 plus 2 negative 13? Yep. So did we do it right? Awesome, possums. What are you going to do with 3? You could do 6 times 9, but isn't there something we're supposed to do first? Divide by 3. To get 3, 2x squared minus 7x plus 3. Now, I got to check where? Here. Oops, that was supposed to be a highlighter. I got to check here. How do I check? Is there a number that multiplies to what? 6 and adds to what? Negative 7. Are there factors of 6 that'll get me to 7? What are they? Negative 1 and negative 6. So, can I forget about this 3? Some of you will. Will I take off marks? Yeah. 3 and then x what? Minus 1, but it's not really 1. 1 over 2 and x minus 6, but it's not really 6. It's over 2. And then what do I do to every fraction I see? Simplify. Can I simplify 1/2? No. Can I simplify 6 over 2? What do I get? 3 over 1, so we just write 3. What do I do with any leftover denominators? Push it to the front. And then I check. Is 2x times x 2x squared? Yep. Is negative 1 times negative 3 positive 3? Yep. Now, so far, if both ends have worked, the middle's worked, right? So do we need to check the middle? No. And then 3 in front of it. Will that get me back to 6x? So am I done? Yes. Is everybody good? Great. You guys try 4 totally by yourself. Yes. Some leadership person. When's this block end?
11, 10,
10:25. Okay, thank you. Okay, it's not supposed to begin an argument. We're fine. It's around 10:20. That's all I needed. Now, as I was saying, there are members of the room that have already done these sheets in advance. They figured out their own way to factor it. That's fine. Are they allowed to continue to use it? Yes. If you don't like this method, are you allowed to go learn another one? Yes. Are you allowed to come and see me and have me show you another one? Yes. I do not care. But believe me when I tell you, this is the easiest thing to do. Having factored about 1 trillion trinomials in my life, this is the easiest way to do so. Would anybody like to walk us through the first? Would anyone like the magic pen?